So now, a redox reaction, it's simply reduction oxidation reaction, and there are two opposite yet complementary reactions. That is how it is. They are opposite yet complementary, just like bread and butter goes together. Which other combination of food do you think can go together now? If we have the food is in the house, which other combination do you think can go together? They are opposite, but when bring them together, they make a very good meal. Like my own, I'm a typical Robo man. So if you give me starch and banga soup, I will appreciate it a lot. Like some other
rice and beans.
Yeah, like that's like how the redox reaction look like. They are opposite yet complementary. You see a situation whereby married couple, the husband uses the wife as a punching bag, but the wife will still remain in the marriage. Say, okay, we die here, like they will say in Pigeon Palace. Yeah. So even with the way the husband is maltreating the wife, he still remains. They are not separated. But that does not mean you should now use your wife or the wife use the husband as a punching bag also. But that's just on a lighter note. So now let's go over to definition of a redox reaction. If you are to define redox reaction is defined under various headings or categories. Based on one, we have oxygen transfer. I can as well say two. Hydrogen transfer. I can say three. Oxidation number. And also we have based on loss or gain of electron. Okay, so sometimes we can even still add 5 based on the addition of subtraction of electropositive or electronegative ions. But these 4 categories is good to go. The students can know this, that oxidation could be defined, or reduction or a redox reaction could be defined in terms of oxygen transfer, hydrogen transfer, oxidation number is oxidation number based, oxidation number, then loss or gain of electron. Can I move on? Please. Are you with me, please?
Yes, sir.
Okay, thank you. So, a general definition of a redox reaction is this, irrespective of these various headings. Redox reaction could be defined as a reaction in which one species is reduced. A redox reaction is a reaction in which one species is reduced while the other is oxidized. Reduced in the sense that it has to do with gain of electron, in which one species is reduced, that is electron gain or gain of electron. Remember this acronym when we're talking about electrolysis, oil rig. Can someone remind me this? What does this oil rig mean?
Oxidation is loss.
Yes, thank you.
Reduction is gain.
Yes, in terms of electron. So I could as well just simply define a redox reaction as a reaction in which one species is reduced, that means gain of electron, and the other is oxidized, that is loss of electron.
Okay.
If that is taken, now let's now define a redox reaction under the following headings, because that is where question comes in. They might ask students to define maybe oxidation in terms of oxygen transfer or in terms of hydrogen transfer. Let's start with the first one. I just write oxygen transfer. And under it, you can just write oxidation. Can I continue? So oxidation is the addition of oxygen. You can write it that way. Oxidation is the addition of oxygen. Oxidation is the addition of oxygen. Why? Remember we said they are opposite yet complementary. So once you define oxidation as the addition of oxygen, reduction will be what?
Removal.
Okay, thank you. Reduction will be removal of oxygen. So let the student know this. It's not that they will start cramming it. Very simple. Oxidation is the addition of oxygen, while reduction is the removal of oxygen. If you get that, let's look at a simple equation. Now you see the equation, please. Can the equation be seen clearly?
Yes, it can.
Okay. So this is copper 2 oxide. This is hydrogen gas, copper, and then water. So if we link this to this place, what has happened? If you check here, there's oxygen here. On going this way, the oxygen has gone off. So what has taken place there? Is it oxidation or reduction? Going by the definition we just gave now, that oxidation is the addition of oxygen, while reduction is the removal of oxygen. So what has taken? Yeah,
Reduction.
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 Thank you. Reduction.
Wow.
Then on going this way, I have added
Oxidation.
oxygen. This is oxidation. Now I'm going to add something here. This copper 2 oxide undergoes what? Reduction. So I'll call here OA. Why this hydrogen here undergoes oxidation, I'll call it RA. I'll tell what else this. The OA here means oxidizing agent. Why this means reducing agent. The one that undergoes reduction is the oxidizing agent. Why this undergoes oxidation is the reducing agent. RO, R and O. Any question? Please. If it's not so clear, you can let me know, so I will throw more light if I move on.
It's very clear.
Any question?
Yes, sir.
Okay. Okay, if it's clear, now let's now look at something. I wrote here OA and RA. So let's put here species. CuO is what? This copper 2 oxide is what? Reduced.
Reduction.
So we'll say reduced. So copper 2 oxide undergoes reduction, or copper 2 oxide is reduced. Why? H2 is oxidized. Again, my CuO is the OA, that is the oxidizing agent, while the H2 is the reducing agent. So most times, what students will see, they can give them an equation like this and ask them, what is the role of CuO in the above equation?
Okay.
In a situation like that, the CuO here is acting as the oxidizing agent. But for them to know if it's the oxidizing agent, they must know which of them is undergoing reduction and oxidation. Once they can identify that, it becomes easier to know which is the oxidizing or the reducing agent. Is that taking place? I need response. Fine, move on. Okay. If that also
He's taking.
okay, good. Then also let's know this. Now we can be asked to define oxidizing agents in terms of oxygen transfer. Maybe define oxidizing agent or reducing agent in terms of oxygen transfer. If you see this page, just like
Yes.
it's just like, for example, you want to maybe rent a house now. You meet those people, house agents or the estate agents, and you tell them your budget. They will go and look for your specific house for you. And in return, they have their commission that you give to them. It's the same thing that happens here. The oxidizing agent here is responsible to supply oxygen.
Yeah.
On my side, you will not tell you.
If you want to define oxidizing agents now in terms of oxygen transfer,
They say they work on here.
please, I don't know where it's coming from.
You need to express yourself. The first time you call, you book.
Oxidizing agents.
The first time you drink.
So oxidizing agents now are chemical species. That is by definition now. Oxidizing agents are chemical species. I don't know where that noise is coming from.
Smart.
So oxidizing agents are chemical species which supplies oxygen and in the process gets reduced. If you are right, that's the definition. Oxidizing agents are chemical species which supplies oxygen and in the process gets reduced.
Yes.
That's it.
Yes, sir. Noted.
Then reducing agents are chemical species which accept oxygen. You can see here now, this hydrogen is accepting the oxygen and in the process gets oxidized. That is reducing agents.
Yes.
In terms of oxygen transfer.
Yes.
To let the student know that this definition is for oxygen transfer. There are various definitions for oxidizing and reducing agents based on the parameters which you are using to define it. So what we just defined now was in terms of oxygen transfer. Any question?
No.
Okay, so let's look at another quickly. I have H2SO4 react with copper to give me
CUS. Okay. Copper is Cu.
Sorry, carbon rather. Carbon. To give me water. That is 2H2O plus SO2. 2SO2 plus CO2.
CO2.
So let's see if this equation is balanced. Is it balanced, please?
Hydrogen is 4. Okay. Sulfur is 2. No, it's not. Wait a minute. Oxygen. I think it's balanced. It's balanced.
Yes, thank you. It is balanced. Now let's look at it now. And let's identify the oxidizing agent and the reducing agent, or the species oxidized, or the species that is reduced in a question like this. So this carbon on what has taken
is oxidized.
Thank you. Is oxidized.
It's oxidized.
Then my hydrogen here is 4. 2 times 2, 4.
So it is a reducing agent.
Hydrogen here is also 4. So we link this one to
yes. H2SO4 is reduced.
Good, reduced.
So it is the oxidizing agent.
Thank you. Oxidizing agent, and this is the reducing agent. As simple as that. So once the student can identify the part that is reduced, it's also very simple. Once you know the reduction, you automatically knows the reduction. So this is reduction. Why this is oxidation. Yes. Oxidation. So if you now care to write, you can just write here now species, reduced, oxidized, RaOA. So which species is reduced? Which species is reduced? H2SO4 is reduced.
No, I can't follow body. For the listener,
Then species oxidized is carbon. Reducing agents, carbon. Oxidizing agents, H2SO4. Any question?
No.
Any question? I have one.
Understood.
Okay, I have one here. If you are true with that, then
Okay.
let me just write one that I saw in one white question. I think that was 1995, number 14.
Okay.
Can I clean this up?
Go ahead, sir.
Okay, thank you. So the question here was, consider the reaction represented by the equation below. This is the equation. Consider the reaction represented by the equation below. In the reaction, YO acts as dash. In the reaction, O acts as dash. The options here are A, as an acidic oxide, B, basic oxide, C, reducing agent, D, a weak base.
Reducing agent.
Reducing agent.
Agent.
Okay. I think it's very simple like that. Now,
yes.
So let's look at another definition. I don't want to bug us with much other questions like that. Please, that help us with the noise, please.
Everything at the same time they wanted to do, Abby.
Madam, move for man, so that noise.
Wait, person, now there's stuff for that, and I call them, they come, Abby.
It's not coming from my end, though.
Okay.
You need to, as in, other people need to mute themselves, except they want to talk.
Please mute your mic. Mute your mic, please. Okay, let's move on. Criteria of defining redox reaction based on hydrogen transfer. Hydrogen transfer. Are we ready now? For this, we'll also start with the oxidation. Now, for hydrogen transfer, oxidation is the removal of hydrogen. Is that okay? Oxidation is the removal of hydrogen. That's what it's here. While the addition of hydrogen. Please, mind. So oxidation is the removal of hydrogen, while reduction is the addition of hydrogen. Is that taken? Is that taken, please? Are you with me? I need response, please. Okay, if you get that, let's now look at equation here. I have 3Cl2 reacting with ammonia to give you HCl and N2. So please, can we balance this equation? Can we balance this equation together? Great scientists. So, okay, to save time, this is 6 chlorine. So we put 6 here. 2 nitrogen, and we put 2 here. So if we link this chlorine to this hydrogen, what do you think has taken place? Has hydrogen been added or has hydrogen been removed? Has hydrogen been added now? This is 6 atoms of chlorine, also have 6 atoms of chlorine. But the only difference now is hydrogen has been added here. So would I say this is reduction or this is oxidation?
Oxidation.
Oxidation. If you say oxidation, that would be wrong, please, because in terms of addition of hydrogen, it is reduction. If it was oxygen, it would have been oxidation. So the addition of hydrogen is reduction, while the removal of hydrogen is oxidation. So this is reduction. And on coming here, hydrogen has been removed. This is oxidation. So if this is undergoing reduction, this is my OA, that is the oxidizing agent, and this is the reducing agent. Are we together? Then we can now simply say yes, species. The species, we have reduced, we have oxidized, reducing agent, and oxidizing agent. So the species that is reduced here is your chlorine, the chlorine gas. The species oxidized is ammonia, NH3. The reducing agent is also your ammonia because it is undergoing oxidation, while the oxidizing agent is chlorine gas. Any question?
Please, I need to throw more light again.
Okay. Where exactly?
When you talk about the reduction and the oxidation.
Okay. We are looking at reduction and oxidation this time around in terms of hydrogen transfer. For oxidation, oxidation is the removal of hydrogen. That is in terms of hydrogen now, not oxygen. While reduction is the addition of hydrogen. Unlike when we're talking about hydrogen, when we're talking about oxygen, if it was in terms of oxygen, oxidation is the addition of oxygen. Then if we're also talking about oxygen, reduction will have been removal of oxygen. It gets confusing, but always know that they are more or less like the opposite. For oxidation, it is addition of oxygen, removal of hydrogen. Then for reduction, it is removal of oxygen and addition of hydrogen. So if that fact has been established, looking at this equation, this is 6 atoms of chlorine. On going this way, and chlorine here is still 6, but hydrogen has been added. So since hydrogen has been added, it is reduction.
Is there ammonia in this house?
Then here, this is ammonia, which is your NH3, 2 nitrogen, 6 hydrogen. The hydrogen which has been removed has been added to this chlorine. So this is oxidation. And obviously, you already know, since this is reduction, this becomes my oxidizing agent, and this becomes my reducing agent. Is that taken now?
Okay, sir. Thanks, sir.
So now, I've listed the species out. Let's now define oxidizing agent and reducing agent now in terms of hydrogen transfer. So in terms of hydrogen transfer, oxidizing agents, what has taken place here now? Hydrogen has been added. So oxidizing agents are chemical species which accepts hydrogen and in the process gets reduced. Oxidizing agents are chemical species which accepts hydrogen. You can see here now, this is chlorine. It has accepted the hydrogen, and in the process gets reduced. That means undergoes reduction. Why? Reducing agents are chemical species which gives out or which supplies hydrogen, and in the process gets oxidized. Is that taking place? If you have any question, you can ask for proper clarity before I move on.
It is taking. That is perfect.
Okay, thank you very much. So we can look at another example now to buttress this point. Let's look at maybe hydrogen sulfide, H2S, reacting with Cl. I should have HCl and then X. So please look at this equation. Is it balanced, scientists? I'm quite sure you know that chlorine is a gas, so 2 should be here. So you put 2 in front of this. So that way it is now balanced. So what is the role of the hydrogen sulfide in this equation? Who can answer that question, please? What is the role of the hydrogen sulfide in the above equation?
A reducing agent.
Thank you. It is the reducing agent. But just so we know, how do we arrive at that? Let the student know this. This H2X and this is X. So on going this way, the hydrogen has been lost. Then on coming this way, hydrogen has been added. So since hydrogen has been lost here, so let me just write the equation down so that I have space to write what I want to write up there. So we'll link this now to this and this to this. So on going this way, hydrogen has been removed. Is it oxidation or reduction? Please, maybe Madam Ufoma or Madam Esther, if you can help us. On going this way, from here to here now, hydrogen has been removed. So is it oxidation or reduction?
Oxidation.
Oxidation. Okay. This is oxidation. Then below it's what?
Reduction.
Reduction. So that means my H2S here is the Ra, and my Cl is the OA. As simple as that. So the role that H2S is playing here is it is acting as the reducing agent, while chlorine gas is acting as the oxidizing agent. Question will not be more than this in terms of wire questions in objective. And that's what you will mostly see in the above equation. What is the role of maybe H2S or this, or which species is reduced, or which species is oxidized? Can I move on?
Yes.
Okay. So let me ask another one that I saw in one white particular year. So I'm going to clean this. Can I clean this? Please, my time is telling me we are less than some 3 minutes to go.
Okay, sorry, before you write the question, so they could just give you the equation. So you have to know oxidation, yes, the definition of oxidation in the different terms so that you can know, yes, right?
Yes.
Okay. Okay.
Please, I will encourage you to tell your students to get a book called PREP 50. Maybe some people are familiar with it already. I always encourage my students to get that PREP 50, PREP 50. Is a compilation of why questions that breaks the questions on a topical basis. Even you as a teacher, if you get it, it will help you. Before you go to class, look at the possible questions as regard that topic over the years in WAEC, so that when you are teaching, it will guide you on what to focus on or how to go about.
What did you call the name of the textbook?
Prep 50.
Huh?
See on the board, Prep 50, PREP, then 50. It's not a textbook, it's a compilation of past questions. So we have pre 50 biology, chemistry, maths, like that. So since you are the chemistry teacher, just get pre 50 for chemistry. It's no more than 1,000 or 1,005 for a copy. So just like it now, I'm holding a copy here now. If you check it now, this is chapter 15, oxidation and reduction reaction. So all the questions in WAEC as regards redox reaction, you will see the questions here. And so you will just be able to, even when you are setting your questions, it's easier to set questions for it like that. Okay, so quickly, let's look at this question. H2X okay, sorry, this is H2X plus 2FeCl3 X 2HCl 2FeCl2. Is that taking place?
Yeah.
Okay. So if I ask a question now, which of them, what is the reducing agent or the oxidizing agent in this question? Can anybody try?
The reducing agent is H2S.
H2S.
Yes.
Okay.
And the oxidizing agent is FCl, iron 3 chloride.
Okay. But how do I arrive at that? If you link this to this, what has taken place here?
Oxidation. No? What happened?
Yes.
Let me look at it again. Okay. All right. That's removal of hydrogen, and that is oxidation.
Okay, that is oxidation. Oxidation. The rest members of the class, do we agree on this?
We are there.
Okay. Now,
Yes, yes.
okay. Now this one, where do I now link this one to? That is
We
this
are linking it to
FeCl3. Where do we take it to?
CL2.
I should link it to this thing.
FeCl2.
You link it to 2HCl.
HCl.
Okay, I should link it to 2HCl.
Yeah.
Yes.
Okay. But I will not link it there. Why? Because I can't bring Cl here and bring my hydrogen here. No. Let's link it this way.
Okay.